Hello, this is a tutorial on 2.2a1. We're going to be comparing rational numbers, and then we're going to do that by converting them all to decimals, and then we're going to compare them using these inequality symbols right here. So, well, we got lucky. This one's already a decimal. It's 0.0356. So that's the form we're looking for. You can think of it as a numeric form or a dollar form because they've got, this would be like 35 cents and then just a little bit of extra. All right, so let's take a look here, and the next one, when you have a fraction, you just put them in just like they're written. This is 1 divided by 10. That's what that means. It's no different than this. So just keep that in mind. So we're just going to put it into the calculator that way. 1 divided by 10, and we're going to get 0.1. So this is going to become 0.1. Now we have to compare these two. Well, I'm going to add on a couple of zeros so that when I compare them, they have the same number of places. So this looks like about 35 cents, and this looks like about 10 cents. This one is greater. I'm going to use that knowledge of money to help figure these things out. So here we have 35%. Well, 35%, let's just think about 25% for a minute. 25% is the same as a quarter, right? So we're moving the decimal 2 places. So really we have 0.25 is the same thing as 25%. Well, let's just move the decimal a couple places here. We've got 0.35. So then we can take and do, we've got 0.35, we made that into a decimal, and then let's just do 2/5. Let's just do again, 2 divided by 5, that equals 0.4. Now, some of you might think that's 4 cents, but it's not. That's 40 cents. So now we've got 0.35 or 35 cents, and we're comparing that to 40 cents. And I think you know right away that this one here is bigger. All right, so now we've got some bigger numbers here. So let's just think about this as money. Let's just see if we have enough information here. It looks like $1.23 to me, right? Take a look at this one. What does that look like? These are both in decimal form or numeric form. So yeah, this looks like $1.02. This one is bigger. All right, let's just jump down here a little bit. Now we have 125%. Well, 125%, just like 25%, made into decimal and moving it 2 places left. That's what we're going to do on the $1.25 too. So we have, 125%. We're going to move it 2 places, and we end up with 1.25, $1.25. You heard me say it just a couple of minutes ago. Over here, so here's what we're looking at here. Let's just look at the money portion of it. Looks like $1.12 to me, right? It's because it is. Just over $1.12. It's got that extra 3 on there. All right, so these here, we're going to use our square root key to do these here. Now, this is kind of a weird one, but I think you could see this on a test in the MAP test, or maybe even the MCA. They're pushing you. So we're just going to take and figure out how to use this key right here, the square root key. And most of the time you just hit 25, you put the number and then you hit the square root, and that works. Sometimes it's backwards, you hit the square root and then hit 25. Let's just try this, 25, square root, 25. Yeah, this one doesn't work. So, but most of the time, 25, the square root key. What does that mean? This square root thing says, that bracket means what number times itself is equal to that number inside there. So of course that is 5. This 5 times 5 is 25. I bet you can guess what the square root of 81 is. What number times itself is 81? Well, in case you don't know, we can just take and put it in. 81 and hit the square root key, and you get 9. It gets a little weirder when you take a number like 4. Oh wait, that's 2. 2 times 2 is 4. That makes sense, right? But let's try 3. Take a look at the square root. Oops, sorry, put 3 and put the square root key. Yeah, 1.732. Let's take an abbreviation of that. Let's take 1.732. Let's just multiply that times 1.732. See how we almost get 3? It's because I just kind of approximated that. But that's kind of cool. Whatever, when you hit that square root key, whatever number times itself, we'll do another easy one here. We'll take 9 and hit the square root key. That's because 3 times 3 is 9, right? Okay, so anyway, we have 5 here, and we've got to compare that to 12. Well, which one is greater? 12 is greater. I'll leave you a few of these to do on your own. Let's see if there's anything else I want to do on here. Let's go down and take a look at some of these numbers down here in the bottom. How about 8 4/5? That's kind of a difficult one. Well, 8 4/5 is like 8 plus 4/5. And that's just the same as 8. And then we're going to take and do 4 divided by 5. 4 divided by 5 equals 0.8. So we're just going to add that on. So this is like 8.8. We're going to compare that to 856%. Let's put 856% up here. And let's just put 225% up here. Remember how we made 25% into a decimal, just moving to 2 places? We'll do the same thing here. So now we've got 8.56. Let's add a 0 on here so we're looking at money. This is $8.80. This is $8.56. Definitely bigger. All right, last one down here. Put these values on the number line, then compare them. All right, so let's just do this. We got, make a little number line here. This would be -1, -2, -3. So let's put these on. Here's -3, and here's -2. I know we're working in the world of negative numbers, but we're just dabbling. Which one of these is greater? Well, when you're on the negative side, the closer you are to 0, the bigger you are. It's just the opposite when you go over here. 1, 2, 3. The farther this way you go, the bigger you get. And the farther you go this way, the more negative you get, so the smaller your numbers get. So let's take a look at this one, -5/16 and a quarter. So let's divide this up. This would be 1/4. Negative, this would be -1/2. -3/4. That's probably enough. So we got -1/4 here. And then we have 5/16. Well, I know that 4/16 equals 1/4. So 5/16 is going to be just right about here, just a little bit bigger. So I'll label that 5/16. Of course, it's negative. Which one of these is greater? Well, which one's closer to 0? -1/4 is closer to 0, so it's larger. And last of all, let's just try this one here. So here, make this 1, make this 2, make this 3. So these are all negatives. So here's -2.5. So -2.5 would be right here. -2.5. And, well, this is where -2 1/4 would be. Which one of those is closer to 0? Well, think about it this way. Throw a 0 on here so we can think about money. Would you rather owe somebody $2.50 or owe somebody $2.25? Here, this one's less. It's less negative. It's closer to 0. This one is greater. Okay, thanks for listening.